Yay.
Okay, well, since Sean's not here and he's got the gavel, I brought my dead blow hammer and a piece of wood. November meeting, September meeting. See, I'm already screwing up. The September meeting of the Back Bay Amateur Astronomers is now in session. And I would like to, first of all, introduce our new astronomy professor, Dr. Leah Flax. Flax. Would you come up here, please?
I can't make the
And,
camera.
our Kenny Broom, who's been with us for over 20 years, retired. And Dr. Flax is now going to take his place. She's going to be a member of our club. Say a word or two about yourself to introduce yourself to.
I'm Leah Flax, and I've been around for a long time here, but I'm new as full-time and working in the planetarium, and we have a great observatory. We're still from home right now. The physics department's teaching from home. So I teach physics and astronomy here, and I love TCC.
Wonderful, wonderful. My son did some classes at TCC. A friend of mine has got his degree at TCC. My oldest granddaughter got her degree at TCC. She's now at Liberty University. And my youngest daughter got a 2-year associate's degree at TCC when she did not want to go to college.
Okay,
We made her go to TCC.
good.
And then she got in business administration. She worked for 10 years in business administration. She thanked us over and over again. And she is the only one, after 10 years of being out of school, she went back to graduate school, finished her bachelor's and got her graduate degree. She's the only one of my 5 kids that's got a graduate degree, the one who didn't want to go to college. So thank you, Dr. Flax. We're looking to see more of you. Okay, time for reports. We'll start off with the Vice President's report, if I can figure out how to do this now.
Share. Hey, you got it. I
And,
don't know if you're sharing it though. You're not sharing.
oh, I gotta go back to share the screen. Back up. Share.
Yeah.
There we are. Okay, this is the schedule for this month, September. Of course, tonight is the club meeting. Tomorrow night is our first corn watch at Cornland Park. Then our night watch at Japoke's Plantation State Park is this Saturday from sundown to as long as you want to stay, till sunset the next day if you want to. Following Friday the 10th is our second corn watch at Cornland, and our sky watch at Northwest River Park on Saturday the 11th. We have a Garden Stars event at 8 p.m. on the 16th, which is a Thursday. And then the following Tuesday is our Boardwalk Astronomy number 5, the last Boardwalk Astronomy for this year. We'll be down at the ocean front behind the 24th Street stage from 6 p.m. till 11. And then the following Saturday, the 25th, is our Saturday Sunday at Elizabeth River Park in Chesapeake from 10 a.m. to 1. Going into October. Come on, October. No, I'm not going to go to October. Oh, well, I guess we're not going to October. But the 1st of October, first Friday in October is Corn Watch at Cornland. The first Saturday in October, the 2nd of October is Sky Watch. And the first Thursday in October, which is the 7th of October, will be our next BBAA meeting. And that's as far as we'll go. Any questions? Any questions on Zoom? Okay. All right. Now reports. Let's have our secretary's report. Yeah. Gordon.
Okay, well, the last meeting we had.
I make a motion that we suspend the reading of the minutes.
Do we have a second?
Second.
All in favor, say aye.
Aye.
Okay, the only thing I was gonna say that the last meeting we had was at the Old Dominion University's planetarium.
I think we ought to read the minutes. I think I'm overruling all these ayes. I wasn't there. I want him to read the minutes.
Are they posted to our website?
You missed it. Yeah, we had a great
Very
meeting
cool.
at the Old Dominion University's brand new planetarium and digital theater. Sean called it to order at 7:30. And that's as far as I think I'll go with it. How about that?
Okay, so what, did they do a sky show?
Oh, yeah, they did a great sky show. We were lucky enough to have, it was a brand new Michael, and I can't pronounce the guy's last name, digital theater and planetarium located campus Old Dominion University in Norfolk. Justin Mason was the planetarium director, and he gave us a demonstration on what that amazing planetarium had to offer. Had a tremendous 4K projection system, and they're holding classes in there, chemistry classes. So they give the thesis, somebody wants to give a thesis, projected in tremendous 3D, or not 3D, but onto the planetarium.
Probably
ceiling.
project the atoms.
Yeah. They had biology things, they had
Oh, man.
anatomy.
Wow.
They showed some different slides of different things they could do.
Wow, that's great. Okay, thank you, Jeff. Now time for the treasurer's report. Rich?
All right. Let's share my screen. But I will mainly report that we have money, which is good. $6,400 in total. 700 in our primary scholarship, 600 in our Georgia June, because we just paid out those scholarships not too long ago, so we'll have to replenish. Not a whole lot of, there's a lot of excitement last month with the picnic, but not so much otherwise. We've been gaining members at a very steady clip, which is a good thing. Obviously, we're up to 100. Well, actually, this will be 160 because another one joined. I haven't processed yet. But I've been putting in 5 to 7 new members per month, every month. So people are interested. We're getting members, so that's driving funds, and it's really, I mean, we're about to where we started the year cost-wise. So all good things. That's all I have, unless anyone has any specific questions for me regarding the funds. And if you want to audit, I will say no. Anything.
Any questions?
Sweet, done.
Thanks, Rich. Let me say this about new members. If you are, any of you new members are watching on Zoom or on here tonight, don't be just a joiner. Be involved, get involved. That's where the fun of astronomy comes in. I joined this club 21 years ago, and I jumped in with both feet, and I haven't stopped running since. It's wonderful. I love it. Okay.
If you just want to send us $23 a year, that's fine with me too.
Yeah, the treasurer doesn't care. He just wants the money, but I'd like to see,
Give that cash.
I would like to see participation. Okay, I don't see our Alcor.
Bruce.
Bruce is not here. I think he said he was going to try to come in on Zoom, but I don't see him anywhere. So Bruce is our Astronomical League correspondent. So I guess we won't have a report from that. We don't have anybody here from the peninsula. Bob Berline is not here, and neither is Bird Taylor. So we don't have a report on the RRRT, the Rapid Response Robotic Telescope. And I don't see a report. I don't see our scholarship chairman either. So, but the scholarship report is we gave the scholarship to Samantha Burris, and she is currently at Liberty University. She's in her second week of classes, and she's doing well. In fact, she's the one that had the big 8-inch Dob, the big 8-inch reflecting telescope. And of course, she couldn't take that with her. It's in her little dorm room. So I gave her a little 80mm refractor with a nice solid Bogan tripod that she can take with her. So I'm hoping she'll have a chance to use it in the dark skies at Lynchburg, Virginia. Uh-oh, what happened here? Here we go. All right. So, old business. Any old business? I've got one item that might be considered old business. We have some of these night sky pamphlets, night sky brochures, which are for sale, fold out with a lot of information about the constellations, and on the back, glow in the dark constellations, summer and winter. And if anybody wants them, they are $5. And I've got another one for the moon. I forgot to bring it with me. It's another nice.
There it is. It's in your,
There it is. There's the moon. Oh, thank you.
yeah, thankfully you got a clear plastic
Sideways,
bin there.
Here's the moon brochure. And it too is fold out. Got a lot of information about the moon. And on the other side, it's got pictures of the moon indicating a lot of the features, including craters, mountain ranges, and even the Apollo astronaut landing sites. So this is a little bit more expensive. I think it's $8. Yeah, $8 for this one, $5 for this one, and we'll sell the two for $10. Okay, that's old business. Anything else? Good. Is there any new business to enact? New business to work on? No new business? Wow. Okay, we'll go into observing reports. What have you seen lately? Rich, go ahead, Rich.
I was posting on Facebook about it, but earlier in the month, RS Ophiuchi, which is a recurrent nova, went into outburst, first time in like 15 years. So I was able to catch it on 3 nights right after it went with my binoculars, print out ABSO charts, and it was about 5th magnitude the first time I saw it. And I was able to watch it go down about 1.5 magnitudes. Then we started getting a lot of cloudy weather. But it was one of those two where you're out there with your star atlas, and I'm like, we're so used to hunting faint things, where it was like, okay, there's that formation in I was going over, I'm like, wait, what's that real bright thing? And look at my chart that's not supposed to be there. I'm like, oh, that's the star. So I got that. Other than that, just working on, I just initiated a new project where there is a professor up at University of Toronto, Dr. Percy, who's like the foremost, like he's big on variable star research, especially long period variables. And a couple of years ago, he published a list of unusual pulsating red giant stars that are undergoing some kind of change in its behavior, whether it's period changes or amplitude changes. And I started looking at there was a list of 51 or so stars, and about half of them are well covered and the other half are not. So I got time on a bunch of robotic scopes across the globe to monitor the ones that are not. So hopefully I can figure out some good things that on top of the ones that projects I already have going, mainly with V20. I know I've talked a lot about V725 Sagittarii, which I'm still getting good data on. But yeah, I did make one rookie mistake. I haven't done a lot of visual observing lately. Most of the stuff I've been doing is getting info from remote scopes, and I made a rookie mistake, because when I went with RS Ophiuchi, I first went nova, I grabbed my binoculars, ran outside, popped the lens caps off, and it was like boom, dew everywhere, and I'm like, and I came in sulking with my wife, left my binoculars outside, sulking to my wife, and she's like, you made that mistake once like years ago, and you haven't made it. I'm like, I know, I'm out of practice. So, but I was able to get that observation later. I just had to wait a couple hours for my binoculars to clear up.
Well, thank you, Rich. If anybody wants to know the LPV guru, he is our long period variable star observer. And he is an expert at that. Eddie, I know you've been doing some observing. Why don't you come up here in front of the camera and tell us some of the things you've been observing with and taking pictures of with your scope?
Oh, wow, okay. Well, as you know, I've been out lately for about a month due to the back injury. And,
This is
just
Eddie
getting
Harris.
into astrophotography. I took some really nice shots lately of Andromeda. Of course, if I've seen it's like M110 and M32 right next to them. They're like at zenith right now. It's incredible. It's so big. That and let's see, lately, Bell Nebula, North American Nebula, they're all out right now. And just the season's changing right now, kind of getting away from some of these planets, even though you can see Jupiter and Saturn right now. They're very clear and they're doing their little moment here. But I've been taking some really nice shots. I just like to share one with you guys. I don't know if you guys can be able to see it well, but
Move left about 3 feet.
yeah, okay. Let's see
A little bit
here.
more. You're almost in the camera. Now you're in frame. I can't move it over. It won't move.
Okay.
Otherwise,
Well,
you would have.
I did have one here. I don't know if you guys can see it, but this is of Andromeda. And it's really coming out
real
pretty
good.
good. I'm very, very happy with it. But I'll tell you, I just got into astrophotography and it's a journey. I tell you what, there's so much to learn. And every time I make a mistake, I'm so glad because I get to figure out what I did wrong and go to the next thing. Okay, when am I going to make another mistake? All right, I made another one. Okay, let me do this now. But now I'm getting people calling me and asking me, hey, how you doing this, man? How you do this software? And I tell you what, for me, I'm retired, and just something to keep me busy. And I love it. I tell you, just soak it up. And my grandchildren. So,
All right.
all righty,
Well,
guys.
thank you, Eddie.
You're welcome.
Eddie just is recovering from, did you say back surgery?
Oh, yeah, back surgery. a couple
He
years
hurt his
ago,
back.
The old back, they said it's not gonna happen again. Well, it did it again. So,
Oh, okay. Well, I'm glad you're up and around.
yeah.
Any other observing
Any
reports?
telescopes? No. just-
Bill Russ, come on. Yes, get in front of the camera. Take your mask off in front of the screen here.
I'll get to shine my face here. Where is it?
You're good, right with the, you can even
Oh,
move, move right a little bit. You're okay, even right.
Snake a little bit.
You're good.
This first meeting I've been to since November of 2019. First meeting I've been to. I'm glad to be back. Pandemic, yada, yada. Last November, I built an observatory in my backyard. And on the whole, it's working very well. And I've been able to see a lot of stuff. I don't have to spend half a day setting it up, knocking it down. Bring the camera in, lock a door, and charge the batteries while I'm sleeping. It works great. So I've seen the last notably good image I made was the Dumbbell Nebula. I was working on some clusters, and they weren't too good because the sky was yucky, especially last week. And there were a few other items that came to pass, and I also, as George said, I have topped off the last 6 years with an article on how to align the telescope to the celestial pole and cut out all of the crap that I put in there from the first edition, which so totally wasn't user friendly. And this worked out pretty well. And it depends on how accurate you want to get. And it get to a certain point, you get down to about 0.3 of an arc minute out of alignment. You can't really do much more than that. My method, I don't think, with any off-the-shelf telescope. But I'm real happy with the results. I'm trying to speed them up, and good thing is the observatory generally doesn't move when you go in the house. So you go out and turn it on and crush your fingers, it will still be aligned. So thanks.
Thanks, Bill.
Very good, Bill.
Yeah, Bill had his article on polar alignment published in Amateur Astronomy magazine. And it's awesome. These can tweak that alignment down to a fraction of an arc minute. It's amazing. Any other observing reports? Jeff?
At the Perseids, I don't know if I can get up there. Well, several of us were here, but
Oh, that's right. We had the Perseid
the
meteor
Perseids,
shower.
we went to Heritage Park, and Heritage Park's this
Windsor.
in Windsor. It's the fairgrounds in the Isle of Wight County, and it's a great big park that nobody. It's kind of a unknown fact that it's a free park, and if you know the right people, which I do, they'll let you stay there overnight. So we got permission to stay there overnight, basically, and we even had Jeff Edmondson. And told him about it, and he was going to go out there and watch the meteor shower too. And I told the policeman, and he stopped me. I said, "Hi, Mr. Policeman. Yeah, we're from the Back Bay Astronomy Club, and we're all set to watch the meteors, and we got permission from Mr. Smith." And he said, "Okay, yeah, because I know Mr. Smith, and he's the head honcho of the whole county." So he was good with it, and he said, "Oh yeah, I'll pass it to all my policemen." And guess what? Jeff Edmondson approaches the policeman turns him away.
Oh, no.
He did. He turned Jeff Edmondson away. And I was so mad. I was so mad about that. So of course, Jeff Edmondson comes at 12:30. But bottom line is, we saw, was it 47 meteors total?
Well, you left early.
I left a little bit early.
Sean and I think it was Dan Pelzel stayed several hours later, even after I left. They saw a total of 73.
Wow.
73 meteors.
Well, we left way too early then. Because I figured it's like a light switch. They cut it off after 1 o'clock or 2 o'clock. And that's what happened one year. They cut it off. They cut the shower off, and that's it. You don't see it anymore. But evidently not. I had to leave because I brought my wife, and there was no porta potty there. So that's another. I was going to bring that up for new business, but I thought maybe we could pitch in for a porta potty. Our rocket club, our rocket club flies rockets there, and we're okay with a porta potty. Maybe we could split it with the astronomy club. A chamber. Now you're talking. Now you're talking old school. But maybe seriously, we could probably get a porta potty for not too expensive. And I'll check into it. And before I make a formal motion, I want to have all the numbers straight. And I'm sure we could split with everybody. But it was a fun time. I don't think there was too many mosquitoes. I had a bunch of bug spray, so it didn't bother me too bad. And we had, what we have, about 10 people out there? Mel was there.
Mel, you, Dan, Sean, Chloe, and me. There were 6 of us. And one that didn't make it. Like I didn't even know about Jeff Lawson.
Yeah.
So
and I invited him, and he tries to get in. We didn't even know he tried to get in. Jeff Edmondson tried to get in, couldn't get in.
Didn't show his badge or?
Yeah, well, he says, yeah, I'm going with the Back Bay Astronomy Club, and the policemen all knew we were there. I told them that we were there, and they said, yeah, we'll tell everybody that the policeman wouldn't let him in.
Jeff Edmondson
I was
is the
so mad.
Channel 10 meteorologist, and couldn't even get through to see meteors. I had my granddaughter Chloe, my 13-year-old granddaughter Chloe with me. She's got good eyes, and I've got old eyes. I saw 20 meteors. Chloe saw 60 meteors.
Now, I saw about half.
She was right beside me.
I saw about half of what everybody else saw.
So anyhow, that was the Perseid meteor shower. Okay, I've got an observing report. 20 years ago, when I first joined the club, just a year after I joined the club, my eyes were still not used to finding those small fuzzy objects in the sky. So I said, I'm going to look at the moon, something I can see. So I did the Astronomical League's lunar program, which is observing and recording 100 objects on the moon, naked eye, binoculars, and with a telescope. Well, that was 20 years ago. This year I decided to start on the Lunar 2 award. They've got another award that you can go for 100 more objects, a little bit harder objects on the moon. And it involves not only observing and recording about them, but sketching a lot of them. And I've been working on that. I got this moon map from Sky and Telescope. I've got this moon map, also from Sky and Telescope. It's got the reverse version. That's upside down. And they've got the regular normal version and the reverse version. And I started in May, and I would be finished by now, except for the weather, because there are certain phases of the moon. You have to see certain items with certain bare minimum of illumination, or just where the terminator happens to be. And just so happens that every month has been cloudy or rainy. So tonight it's supposed to be clear. And we're on a 25-day-old moon, and I'm hoping I can finish up my last 2 observations tonight and finish that project, that program, and send it in to the Astronautical League. Well, that's my observing report. Any others?
Oh, yeah, so at Garden Stars on August 12th, we had a good, how many folks? We had about 15, 20,
15. Yep.
15 or 20. And we were setting up our scopes that night in the courtyard, and I saw a fireball for the first time. It was, you saw it also.
Yeah.
I was setting up my scope and I just saw a shadow of something was casting a shadow on the ground. I turned around and there it was. 3/4 of the, quarter of the sky with an orange
Wow.
fireball that lit up the sky for about 5 seconds. Would you say 5 to 7?
Yeah, yeah. And I had jokingly asked George, because we were outside setting up, he was still inside getting ready for the people to arrive. And when I got there, I was like, do you think we'll actually see the meteors while we're here tonight? He said, oh, not unless they're very bright. It's early in the evening still. And sure enough, we're out there setting up, and yeah, it was as bright as it could be.
Yeah, we're right next to the airport, so it's pretty light polluted, but there's no way you're gonna miss that thing.
Absolutely.
Yeah, and one other thing, we had sky watch this past Saturday. We got there and it was fairly cloudy to the south and to the west and to the north, sort of clear to the east. So we were hoping to see something. So we saw Saturn when it came up, we saw Jupiter when it came up, and pretty soon the clouds moved away and we had a nice night. We had about 8 or 10 telescopes there at Skywatch. We didn't have very many visitors, but the ones we did have were really interested and really enthusiastic. We're so glad they were there. There's one dad with his 6-year-old son got this telescope for Christmas 2 years ago, but still didn't know really how to use it. So I helped him tweak the finder. That finder scope was really, the red dot finder was really hard to get adjusted, but I finally got it adjusted for them, and they were happy as clams. And so they were glad they came. Okay, any other observing reports? Well, let's see.
There's a chat, click on that chat, and maybe somebody's got one.
Yeah, let me look in it. There's 4 things in the chat. Where's the mouse here?
Can you guys hear me?
All right.
Not related.
Okay. All right.
Can you guys?
Not
hear me?
related. Okay, that's from Sean and Rich talking about money
Oh,
again.
Sean's on it.
All right, almost 8:15. How to get out of chat?
You can exit, I think.
That little drop down arrow, if you click it.
That one?
it'll say
There you go.
close it.
Hello?
Close. Okay, good. All right. I'll say one more thing about money. We did have several boardwalk astronomy events this month, and we do get paid by the city of Virginia Beach for each one of those, which always goes into our scholarship fund. But we can always, like we did last year during COVID when we weren't getting anything like that, any input, any income that we get from the members is tax deductible. So if you want to give $10 or $20 or even $5 a month or something like that, feel free, and it'll all go into the scholarship fund. Just designate it when you send it in PayPal or send it in a check form. Just designate scholarship fund, and that's what it will go to.
Can you guys hear me?
Yeah.
Hey, who's that?
Sean.
Oh, hi, Sean. You look like a moon. He's mooning us.
I've been trying to get my mic working for like 10 minutes now.
Well, it's working now.
Okay, I have the Alcor report from Bruce.
Oh, okay, good. Go ahead.
The reason he's not there is because he
He's out of
was
town.
RV camping at OBX. But anyway, he said the AL virtual convention was a great success. I attended virtually on August 20th and provided a 3-minute narrated PowerPoint on the BBA as requested by the Astronomy League. Thanks to George Reynolds for the PowerPoint material I adapted to the narrated PowerPoint. There were many good talks and I saw several BBA members virtually attend as well. I listened to a great talk on the radio astronomy very large array in New Mexico. Our winner for the 3 hardbound volumes of Burnham's Celestial Handbook was Chris Adrian of Missouri. And I will be mailing him his prize this week. And for Rich, he said he will provide a receipt once he mails the prize. And that's it.
Okay, very good.
Want to make sure we get that into the record.
Yes, thank you. Thank you.
Welcome.
Okay, well then it's time for our meeting feature. And it's something different tonight. It's a step back in time, actually. A little bit of BBAA history. Back in 2006, 15 years ago, the BBAA gave a presentation to a men's retreat at Silver Beach, which is a very, very dark sky, YMCA camp up on the Eastern Shore. And we gave a presentation, and little did I know, they videotaped our presentation. So, and the pastor who was in charge sent me a copy of the video on a DVD. And so that's what I'm going to show tonight. So it's a little bit of history, what we did back then, and it's still current, although I will make a couple corrections. Back then, I mentioned that Andromeda galaxy was 2.2 million light years away. Well, since then, they determined it's 2.5 million light years away. So it's a little bit farther away than they thought. And there might be another 1 or 2 things that need correction in there too. But anyhow, let me show you the beginning of our presentation. Then I'll go ahead right into the presentation itself. I hope I can do this. Press the button. Uh-oh, where the lights go? This thing doesn't light up now. What's it?
No, it's probably went to sleep.
Went to sleep.
HDMI thing.
I'm always technically challenged when it comes to these things.
It's probably sleep.
Oh, I tapped it, but I tapped it a little bit better than I
You gotta
did.
hit hard.
Okay. Okay, can
I hope
you
it goes to Zoom.
see this in Zoom? Can you Zoomer see this?
Lost them.
No,
You want me to make it so they can see it?
Yeah,
yeah, you need to share it.
because it's on a different computer, so.
Oh, it's on a different computer?
Yeah,
Oh, can you,
I've got a
can you put it on that
I
computer?
brought a DVD player.
I've got a DVD.
The actual, I can put the DVD in.
Well, if you move the camera up some, you're like,
Well,
we can see most of it.
Yeah, but-
There's not, no, there's not one.
Could you see it, Rich?
Oh, yeah, we can put it
I
in.
can see a quarter of it.
Up and zoom in, you could.
I couldn't,
Oh, just
I
put the
couldn't-
camera on that.
I couldn't get the camera to move right now.
Oh, yeah, you
What
can,
about using the DVD?
yeah, I can,
Can you
should
do
be able to,
that?
yeah, I should be able to pull that up.
Can she do that?
Do you have a DVD player?
Yeah.
Okay. We're gonna try the DVD player for the school
Or
here.
maybe manually?
Excuse me, can you hear me?
Yes.
Yeah.
That's
Is it
George.
It's Leah.
You know him?
Oh, hey,
Outside, George.
Hey, just setting up for a night of astronomy, taking picture of Pluto tonight.
Good.
George gets some extra credit.
Sounds good.
You can see one of your students.
Hey, while we got George on the video there, Hey, George, that was a great post you made on Facebook about your Jupiter and Saturn picture taking. That was awesome. As a matter of fact, you kind of got me inspired to go ahead and start astrophotography stuff. So thanks.
Well, I'm glad. Thank you. I appreciate it.
Sometimes this is difficult.
Go to the media.
Yeah, we might.
Oh, wait a minute.
I'm trying to remember. There's a trick to this. I haven't taught here in a year and a half now.
See the DVD down the bottom in the middle?
Yes,
There you go.
I don't think
it
that
should
one.
just come up, but it doesn't. Did you want to try?
Let me try.
There you go. What's that? 3 items on the disc.
No, that's.
I'm trying to remember how to do this. We've been teaching from home for the past year and a half. And there's like little tricks to.
Oh, there's a way.
Hold on. I think I remember. Go into files, like just get out of media player, and you might need to open it like from.
No, that won't work.
It won't.
I've tried it before. Open-
I brought my standby
Here we go.
actual
Here we go. Here we
USB
go. Here we
drive.
go.
Yeah, wait a minute.
Okay.
Maybe you can do it that way.
It's working. No, I need to share this.
Now you want, yeah, so go to over here. So you want to escape out of that. And then go over here. Share sound. Share sound. Yep.
I'll sit over here with Autumn. Oh, watch it, watch it. Hey, you did it. We tied it in. Now we slipped the next one. I'm tied on the leg.
Okay, that was us setting up.
George is 10 years younger.
I was 10 years younger, 15 years younger.
15 years
Okay, let's go to,
younger. And now they're seeing it, I hope.
Yeah, we see it.
we go to minute number 7. This beginning of the presentation. Here we go. Enjoy.
Okay, now we both need to reach to the heavens.
On the actual, on this thing.
Okay, there it comes. Those are the men.
And God called the sun on his earth. And the heavenly of the waters called he things. And God saw that it was good.
God created the heavens. God created the universe. You may ask, what is the universe? Simply put, the universe is a huge space which contains all of the matter and energy known to exist. We're here this evening to paint a mind's eye picture of the nearly incomprehensible size
Now you turn their volume
and
down.
scale of our universe. Before we start our voyage to the outermost limits of the known universe, let us talk about the size of some familiar objects. Have you ever stood gazing up at a large building or looked out over a city? Perhaps you have pondered the vastness of an open desert or stood at the edge of the Grand Canyon trying to contemplate the expanse. Or maybe you've looked over the foothills of majestic mountains in the distance. And who hasn't stood by the ocean, the largest geographic feature on Earth, and felt small and insignificant? Now picture yourself viewing Earth from a space station. There was once a time when our little planet seemed immense, when it was the only world we could explore. Its true size was unknown. Today, we know a lot about our small globe, the third rock from the sun. An even larger familiar object, the sun. The sun is approximately 863,000 miles in diameter. The Earth is a mere 7,930 miles in diameter. It takes just over 109 Earths to span the face of the sun. Our moon's orbit is approximately 483,000 miles. If the Earth was in the center of the sun, the moon would be almost 200,000 miles inside the sun. The sun seems to be a really big object, but how does it stack up against other structures in the universe? George Reynolds will now take us on a scale model journey to the edge of the universe. George.
Who can look up at a star-filled sky without feeling a sense of awe? To even the most casual observer, this panoramic display captivates us with its beauty and wonder. Although we readily marvel at the night sky, it is far more challenging to grasp the true character and size of the cosmos. Yet, the more we understand, the more we can appreciate the majesty of the heavens. Let's begin a journey then, a journey that will take us far into space and back in time to discover what mysteries the universe might reveal. To help us navigate this vast expanse, we will organize our travels into 3 segments, beginning close to home and venturing further out with each step. First, we'll look at interplanetary space, the region of our solar system. Second, we'll step further out into interstellar space, where we find all the stars that we can see with the naked eye, lying within that wondrous river of light, the Milky Way galaxy. And finally, out even further, we'll enter intergalactic space, the realm of the galaxies, those island universes that gather in clusters and superclusters farther and farther out and back to the origins of the universe. We begin at home with our own star, the sun, and its collection of planets. To better appreciate the size of our solar system, we will scale it down to dimensions we can relate to. Let's create a model solar system where 1 inch equals 100,000 miles. Think about how long it takes to put 100,000 miles on your car. At this scale, the Earth shrinks to the size of a peppercorn, and the sun is as big as a bowling ball. How large a room do you think it will take to fit our scaled-down solar system. Actually, it won't fit in a room. We'll need to go outside for this exercise. Maybe a football field will be large enough. Let's start with the sun, our bowling ball, at the goal line and place the planets downfield toward the opposite end zone. As we walk downfield, we first come upon the planet Mercury at the 10-yard line. Mercury is pretty small too, no bigger than the head of a pin. Continuing our walk, we next find Venus, 19 yards from the sun. Venus is about the size of a clove, slightly smaller than our Earth. Next, the Earth at 26 yards. Remember, the Earth is the size of a peppercorn. Farther downfield is Mars at the 40-yard line. This is the last planet we can fit on this field. We'll have to add another 100 yards because Jupiter is 135 yards from the sun, almost 1.5 football field lengths away. By the way, Jupiter, the largest planet, is about as big as a chestnut or a Sacagawea dollar coin, almost 1 inch in diameter. Moving on, we find we need a third football field to get to Saturn at 247 yards. We must add a fourth and fifth field to arrive at Uranus at 496 yards. 8 fields are needed to reach Neptune at 777 yards. And finally, 11 football fields away from the sun, we find Pluto, not even a pinhead, at 1,019 yards. This makes the diameter of the solar system 2,038 yards, or about 1.2 miles. If we could look down on this scene from, say, a 20-story building, we would see the sun, a point of light, in the center of a vast expanse of empty space, interrupted only rarely by tiny specks of matter, the planets. How far, you may ask, is the nearest star, Proxima Centauri? At this scale, with the Earth the size of a peppercorn, Proxima is located 3,763 miles away, or as far as the Straits of Gibraltar are from Virginia Beach. Now there's something to tell the kids the next time you're making sand castles at the beach. Moving beyond our solar system, we enter the realm of interstellar space. Inter meaning between and stellar meaning stars. Go outside on any night, especially away from city lights, and look up. All the myriad stars stretching across the sky are part of our home galaxy, the Milky Way. It is this starry vault that is the next step on our journey. Before we venture into this new arena, however, we must define another distance scale. To measure the vastness of interstellar space, we will use a unit of measure called the light year. A light year is the distance a beam of light can travel in 1 year and equals 5,865,700,000,000 miles, or approximately 6 trillion miles. To get just an inkling of the enormity of this distance, consider that light travels at 186,000 miles per second. At this speed, a beam of light can travel from Earth to the moon in 1¼ seconds. It takes 8.3 minutes for light to reach us from the sun, 5.5 hours to travel from the sun out to Pluto, and 4.2 years to reach the nearest star, Proxima Centauri. Remember our solar system on the football fields? We must now shrink our model solar system down again. In this new scale model, our mile-wide solar system must be downsized even further. this time to a disk that's now only 2¼ inches in diameter. At this scale, 1 light year will be equal to 160 feet. The Earth is reduced from a peppercorn to a microscopic particle of dust, just 1/30th of an inch from a pinpoint of light that is the sun. The nearest star, Proxima Centauri, has moved from Gibraltar in our first model to a point much closer. It is now 672 feet away. Sirius, the brightest star in the night sky, is 1,376 feet, or 8.6 light years away. Other bright stars that we see in the winter constellation of Orion and Taurus are much more distant. Aldebaran in Taurus, at 65 light years, is 2 miles away. And the supergiant star Rigel in Orion, 777 light years from Earth, is 23 miles distant. In our new model, the average distance between stars is about 600 feet. At this scale, where 1 light year equals 160 feet, and our solar system is 2¼ inches in diameter, how big is our galaxy, the Milky Way? The Milky Way galaxy is a staggering 3,000 miles in diameter, or about the size of the North American continent. Our sun is located in one of the spiral arms, about 26,000 light years from the galaxy center. So if we were to place the galactic center in Fargo, North Dakota, our sun would be near Cincinnati. Ours is a spiral galaxy containing roughly 400 billion stars. It is estimated to be 100,000 light years across and 10,000 light years thick. From our vantage point in a spiral arm, we see much more than individual stars. There are double and multiple stars orbiting each other. Loose clusters of stars, such as the Hyades and the Pleiades in the constellation Taurus. Remnants of dying stars, like the Helix Nebula, also called the Eye of God. And in a distant halo around the galaxy, giant globular clusters of stars. The Hercules cluster, seen here, contains hundreds of thousands of stars. There are also immense clouds of star-forming hydrogen gas glowing in the ultraviolet light of young stars. One such cloud is the Great Orion Nebula. If we were to pass over our model galaxy in a spaceship, we might not discern individual stars. Rather, we would see these 400 billion stars laid out over North America like enormous clouds of light forming the spiral arms. This is our home galaxy, our island universe. In the third and final step of our journey, we move out of our home galaxy and into intergalactic space. Before the early 20th century, the Milky Way was thought to be the sole galaxy in the universe. Although the existence of spiral nebulae had been known for centuries, it wasn't until 1924 that Edwin Hubble first successfully measured the distances to a number of these mysterious objects. Once Hubble determined that the spiral nebulae were located well beyond the boundaries of the Milky Way, he realized they were not clouds of gas, but galaxies, island universes unto themselves. As we look out at the night sky, the most distant object we can see with the naked eye is the Andromeda Galaxy. It is 2.2 million light years away. This galaxy, containing billions of suns, appears as little more than a faint, almost imperceptible glow. It is amazing to consider that the photons of light reaching us tonight from Andromeda began their journey 2.2 million years ago. And if this galaxy ceased to exist at this very instant, photons currently en route would keep on coming for another 2.2 million years. So when we look at Andromeda, we don't see it as it is now, but as it was millions of years ago. Before we can begin to imagine the incredible distances in this realm of the galaxies, we must downsize our astronomical model yet again. This time the Milky Way, which had been the size of North America, must shrink down to a disk about 30 yards across. In our third scale model, 28.2 yards equals 100,000 light years, the diameter of our Milky Way galaxy. At this new scale, our sister Andromeda galaxy is about the same size as ours and is located 620 yards away. Within a half mile, or 3 million light years, we can find nearly 30, mostly dwarf galaxies, known as the local group. Extending our search out to 50 million light years, we come upon our first major cluster of galaxies, the Virgo cluster. Its 2,000 member galaxies stretch across 15 million light years. In our model universe, the Virgo cluster is found 8 miles from our own local group of galaxies. The Virgo cluster, our local group, and several other clusters are all linked gravitationally in a 100 million light-year wide tapestry known as the Virgo supercluster. In our model universe, this supercluster extends for 16 miles. As we look deeper and deeper into space, we see repeated patterns of galaxy clusters and superclusters. This pie slice of space plots positions from a survey of nearly 250,000, 250,000 galaxies. Note that the galaxies are not arrayed randomly, but are distributed in a convoluted pattern of sheets that are connected in a manner similar to the way a mass of soap bubbles appears in a kitchen sink. Each individual bubble represents a galaxy cluster or supercluster. The superclusters can spread as far as 1 billion light years, which would be 160 miles in our model. As we will look out ever further, as we continue to find more and more distant galaxies, and as we look out, we also look back in time. The deepest image of the universe ever taken in the visible light spectrum is the Hubble Ultra Deep Field, taken with the Hubble Space Telescope. It shows a sampling of the oldest galaxies ever seen. Here we view galaxies as they were 13 billion years ago, when the universe was only 5% of its present age, as determined by scientists. The most distant object yet observed is a primitive galaxy at 13.2 billion light years, 2,080 miles in our model. However, the universe itself is believed to continue for 78 billion light years, or 12,480 model miles in our model. This model distance carries us to the opposite side of the globe. Our model universe, therefore, covers the entire Earth. How would the night sky in our model appear from, say, China or Africa or the South Pole? Actually, the universe looks much the same from any vantage point. Just as looking out at the ocean from one beach appears much the same as it would from many other locations, no point in space is unique. There is no center or edge to the universe. Well then, just how far out and back can we see? We can see as far as the cosmic microwave background. This is an image of the universe when it was about 400,000 years old, a time before stars or galaxies existed, when space had just expanded and cooled enough for neutral atoms to form. This was the first time that photons could travel freely through space. Those original photons are still reverberating, though at wavelengths much longer than those of visible light. We can't look back any farther because before individual atoms formed, the universe was opaque. Light could not penetrate the darkness. Doesn't that remind you of Genesis? We're now pretty far from home. Let's head back. Kevin will now guide us home. Kevin?
We are now standing at the edge of the cosmic abyss, 14 billion light years from our home. Do you see that scattering, that small fraction of galaxies that are close to our home? As we journey home, keep this in mind, that each dot of light is not a star, but an entire galaxy, each containing hundreds of billions of stars. We are now traveling home at speeds that would have made Captain Kirk and his crew very envious. Traveling 14 billion light years in just a matter of 3 minutes. Here at 1 million light years, all you see is whole galaxies and cluster of galaxies. Again, those are not individual stars, but entire galaxies. 10,000 light years, nothing but galaxies. Our Milky Way is now coming into view. Here at 1,000 light years, individual stars are just starting to become recognizable. "100 light years, nothing but stars." "10 light years, our sun is just barely visible." "1 light year, our star starts to dominate the night sky." "10 billion miles from home." 1 billion miles. 100,000 miles. Sorry, that was a billion miles. 10 million miles. "10,000 miles from home." Our home, an infinitely small speck of matter on the scale of the universe, comparatively many times smaller than a single cell organism is to us. And welcome home. When describing his extraordinary work in astronomy, Edwin Hubble concluded, "Eventually, we reach the dim boundary, the utmost limits of our telescopes. There we measure shadows, and we search among ghostly errors of measurement for landmarks that are scarcely more substantial." Like Hubble, we have reached the end of our exploration to the furthest reaches of space and time, and back again. And in so doing, we have come to recognize that truly the history of the universe is written in the stars.
That was pretty impressive, wasn't it?
Stop sharing. There we are, back again, back to home. That was a lot of fun to do. We did that. Hard to believe we did that 15 years ago. And I still enjoy doing amateur astronomy, doing outreach. Our club's motto is, of course, bringing astronomy to the people of Hampton Roads.
And beyond.
And that's what we do.
And Richmond too.
And Richmond, and, yeah, wherever we go. So that is our feature tonight. Any questions? Well, let's see what time is it. It is 8:20 to 9 rather. So if there's no more business or nothing to conduct, meeting adjourned.
Very good. Stop recording button. See that black one? Stop recording. That's it.
Thank you.
There, stop recording. Yes.